We use distance measuring in our day routine at many cases. We have equipments like tapes, rulers, and etc. Today we are going to make a device powered with Arduino to make distance measuring easier and more useful. Okay guys, let's have a quick look at our distance device. We have four main components here. The first component right here is the ultrasonic sensor, the usual sensor we are using to get some distance reading for our obstacle projects like obstacle avoiding robots and etc. And I have Arduino Uno board right here, the usual guy I'm using always. And I have a liquid crystal display right here. It is a 16 by 2 type of LCD display, and I have I2C communication circuit right here because otherwise you have to work with a lot of jumper wires with your pins right here, and most of pins will be allocated. It's for LCD and you don't have much room to work with. So I'm using I2C. Don't worry, I'm going to explain how to do that work as well. And let's have a look at the wire connection right here. And first I'll give a quick look at I2C circuit. This I2C circuit has 4 pins. One is called as the GND, the ground pin, and I have VCC, and I have SDA, and I have SCR. The VCC goes for positive 5 and GND goes for ground pin. SDA goes for A4 analog 4th pin, and SCR goes for A5 analog 5th pin. You can see here there is a small box like thing to mention this. This is the 16th pin right here they are mentioning, and in your LCD when you give the connection, even it has pin connections from 1st to 16. So this 16 right here should be aligned with this box shaped thing. Connection is perfectly done there. So that's how you are connecting this I2C circuit with the liquid crystal disc, so you don't have to work with these connectors and connect them with jumper connectors straight away to your Arduino board and lose lot of digital pins for LCD itself. So you have more room to work in your Arduino board. And this guy is called as the ultrasonic sensor. This is the usual sensor we are using for most of cheap projects. HCSR-04. It's very cost effective and it has some limitations, I agree with that, but still it's okay for some projects with low budgets. The main components of ultrasonic sensor can be seen here. The transducers, there are 2 transducers. Let's see the technology behind this guy. And the pins are like this. We have the ground pin, and we have the echo pin, and I have the trigger pin, and I have the VCC pin. So those things are connected here with jump connectors to my Arduino board. And VCC and the ground pin here and here in the sides are usually connected to positive and ground of my Arduino board. And these 2, trigger pin and echo pin. Trigger pin goes to 12th digital pin and echo pin goes to 11th digital pin right here. If you can clearly see it, I have connected them to 11th and 12th. I have taped it to make sure there is no loose connections in the circuit. And the power, of course, I have 2 components to power up with, the I2C circuit right here and the ultrasonic sensor right here. So I am taking this power to my breadboard and I am connecting them relevantly to VCC and ground through my breadboard connection, and I have even taped them to make sure there is no loose connections, because loose connections would mess up the whole process. And let's have a quick demo of how this thing works. So you can see how this thing works. I can put up obstacles in front of these transducers of the ultrasonic sensor, and the next thing happening is ultrasonic sensor is getting the distance from the object to the ultrasonic sensor, and it's going to send that data into my Arduino board, and Arduino board is processing that data, and it gives an output using this LCD display right here. And in the LCD I have not only mentioned the distance in centimeters, it shows in 4 different distance measurements. It shows in centimeters, it shows in meters, and it shows in inches, and it shows in feet as well, because all these measurements are very important in industrial applications. So I have programmed this whole thing to measure the distance in all these categories, so you don't have to worry about calculating them later using your calculator or converting this information into relevant units by yourself, because this thing does it in a flash itself. So that's how this guy works, and let's see if this guy works precisely or not. Let's check the precision with a small test. So in this setup I'm going to use a small scale in centimeters, and within the other side I have inches. So I have kind of kept it as closer as possible to the ultrasonic sensor. There will be a small error because here there is a small gap, so the error will be somewhere like 2 millimeters. Let's have that in our mind that it has a 2 millimeter precision error, but still I'm going to use a small object like this to see if it is actually working. So I'm going to start the demo with 10 centimeters. I'm going to keep this object exactly at 10 centimeters, and you can see in the LCD display it says 10 centimeters, 4 inches, 0.1 meters and 0.33 feet. And let's have another try. I'm going to keep this object like somewhere like 15 centimeters, and let's have a look at our LCD. The LCD says 15 centimeters, 6 inches, 0.15 meters and 0.49 feet. That's the exact figures we need. I'm going to change this distance measurement into a little bit further, and I'm going to keep it somewhere like 22 centimeters. Here in my LCD display it says 22 centimeters, 9 inches, 0.22 meters and 0.73 feet. So let's have a look at the inches side, because we have inches working here. So I'm going to flip this ruler into inches. That's it, very simple. And let's keep the object in exactly 3 inches. So this is 3 inches. The LCD screen says 3 inches, 8 centimeters, 0.8 meters and 0.27 feet. Let's have another look. Let's have somewhere like 5 inches. So at 5 inches the LCD screen says 13 centimeters, 5 inches, 0.13 meters and 0.42 feet. So those are the correct values. You can see how the guy works, and let's see how to code this guy in Arduino IDE. Okay, let's have a look at the code. During the first 2 steps I have included the libraries I need. The first library I need is the Virage library. Virage library is about I2C communication. Usually it is coming built-in inside my Arduino IDE when I install it, so you don't have to install it yourself. And next library I have used is liquid crystal I2C.h, which is the LCD I2C library. This thing is not coming built-in when you install the Arduino IDE, so you have to go to GitHub, search for it and download it yourself and install it. So when you download it, you will get a zip file, and then you can go to sketch, and there you can go to include library, and there you have @zip library. So you select the zip file you downloaded, and then it will be installed. Unless you install it, you can't work with it, even though you can code with it. So next thing is creating the LCD object. So I am taking liquid crystal I2C, and then I am giving a name. Now in this scenario I am using LCD as my name. It shouldn't have to be LCD always. You can use any term you want, but make sure even within the code you are using the same name to call the LCD. And after that I have a bracket. This is very important. In most of videos it's not said what the hell these numbers are. And there are 2 separators with commas, and here I have the address for liquid crystal I2C communication. I have an address usually, and that is 0/27 in most of cases. And next thing I have is the column and the row. The first guy is for column. Now I have already used my LCD display, and inside the LCD display I have 16 columns and 2 rows. And you have another version of LCD displays which is having 20 columns and 4 rows. So if you're using 20 by 4 LCD display, the column number should be 20 and the row number should be 4. And if you're using 16 by 2 LCD, instead of 20 and 4, you're using 16 and 2. So within this code I am using 16 and 2. So address, column and row. There's no bigger magic here. Those are the values I have kept for my communication. And during the next 2 lines I am working with my HCSR-04. I need to declare a pin for my trigger. So I am declaring 11th pin which I have connected with my trigger in my HCSR-04 as the trigger pin. So I call it trig. And 12th pin I am defining it as echo, which is the receiving transducer. And next I need a variable to hold the distance. So I need to get the value of this variable to next segment. So I am declaring it right here. So the variable type I am keeping it as float, because I need floating point numbers, because I am calculating for meters and feet which contain decimal values. So I take the value from float and I am calling the variable as dist, corresponding for distance. So next thing is the find distance part. Now usually we have these things inside the loop part, but what I am doing here is declaring a function before that and calling the function in the loop whenever I need it. So that's very simple and very easy way of coding, and it's very easy way of organizing your code and working with your code, very easy to understand after that. So what I'm doing is I am declaring a function to get the distance whenever I need, whenever I call for this function. So let's see how that function works. I have named it as find distance. To say it a function I have to use a bracket, an empty bracket, and after that I have the braces to say what this function is about, and within that I am saying what to do when this function is called. And within that, first thing I am doing is I am digital writing the trigger pin high. So once I write it, the trigger pin is sending ultrasound waves in a frequency of 40,000 Hertz. And next I am keeping a delay of 2 microseconds. You know, 2 microseconds is a very small time gap, and within that time gap, that ultrasound wave will be touching the obstacle or the object, and then it will be coming back to the echo end. And digital write trigger low is lower in this trigger, so no more ultrasound waves will be sent since then. And echo pin will be detecting the time taken to receive them back when they get reflected from the object. And I am calculating, this calculation is very important. In the calculation I am taking the pulse in. Pulse in is the time taken for echo. So I am keeping the echo high and I am taking that pulse in time taken, and I am dividing it by 2, because I already told you that HCSR-04 have 2 journeys, ultrasound triggering from the trigger transducer to the object, and then from the object to the echo there are 2 journeys. So what I need is 1 journey from that, either the trigger to object or object to echo. So I am dividing that whole time by 2 so I can get the distance in between the object and the ultrasound sensor, and then I am dividing it by the speed of sound in air, and the most sold value is 28.9, and then I am keeping a delay of 100 milliseconds. So that's how this function works. In the setup part, I have initiated the LCD and I have initiated the LCD backlight, and I am setting up this trigger pin as output, and I am setting up echo pin as input by pin mode trigger output and pin mode echo input. And during the loop part, first thing I am doing is I need 3 variables to calculate these values for meters, inches and feet. So for meters I am making a float which is met, and I am making a float for inches called inch, and I am making another floating variable for feet called feet. And next thing I am saying the Arduino to find distance. So when this line is executed, this function will be done and distance value will be taken. And next thing is I need to display the centimeter value in my LCD. Now for that I need two commands, that is set cursor and print. Now set cursor means the cursor goes to the right place in my LCD to start the printing, and print means whatever should be printed. Now in the set cursor command, the first part is for the number of column, and the second part is for the number of rows as usual. So the first row is named as 0 and the second row is usually named as 1. And here 0 is the first column, and we have 16, which means the last column is like 15. So 0 to 15 you have completely 16 columns and 2 rows. That's how they are named. So here set cursor is taken to the 0th column and 0th row, which means the beginning place to keep the cursor. And next I have printed the distance straight away because I need it in the centimeters, and when you calculate this originally by 28.9, it is coming for centimeters. So I am putting it under round. Now round is not usually a built-in command of Arduino, but it's there with C language, so it actually works in Arduino, but it's not a built-in command. But what round does is neglecting that decimal parts and just put in the whole number. So in the centimeters part I don't have to put all those decimal points, because usually this ultrasound sensor got some errors of 0.1 positive or negative centimeter of error. So I'm not interested about that part. I just need the whole number, the whole value. So I'm rounding it up and I'm keeping it as the distance. And then right after that I need to mention the unit. So I am saying LCD print centimeters cm. So when you put text should be within quotes. Make sure you are keeping it within quotes, because if you're dealing with numbers or mathematical expressions or variables, whatever, you don't have to mention it inside quotes. But when you deal with text, you need to. So during the second part I am making the meter display. So meters means you know that centimeters are divided by 100 to be converted into meters. So I am doing exactly the same. So meters assigned with distance value divided by 100, and then I am setting the LCD cursor into 0, but this time the row is first row, which means in your LCD the upper row is mentioned with centimeters in the left corner, and the lower row in the left corner is mentioned with the meters. So I'm keeping the column as 0 because I need to start there itself, and I am printing the value I obtained for meters, and next I am keeping meters as the unit. The same goes with inches. So inches means you take the centimeters and divide by 2.54, you get inch value. That's the usual conversion method. So I'm doing exactly that. Inches assigned with distance measurement in centimeters divided by 2.54. The LCD set cursor command sets the column to 8 and the row is 0, so it is not exact center but it's very close. And next I am printing the round value of inches, because there also I don't need the decimal parts, I just need the whole number value. And next thing is I need to put some sort of a unit, but for inches we are using quotes, but quotes are not much appropriate, so I am keeping in as the unit. Anybody can understand very easily with in. And the last part is displaying the feet. So for feet, usually you take centimeters and divide it by 30.48, you get the feet. So I'm doing exactly the same. Feet assigns with distance value divided by 30.48, and I am putting the cursor using set cursor command in the same 8th column, but this time the row is first row, which is the second row or the lower row in your LCD. and the LCD print command is printing the value you took for feet. The next LCD print is printing the unit for feet, so I am using FT as the unit to mention feet. And after that, what I'm doing is I need to continuously do this. I mean, I should get values continuously, but there should be a time gap which is sufficient enough for someone to actually read and understand what the hell that LCD says. So I need to keep a delay of 3000, which is 3 seconds. So 3 seconds is enough for anybody to understand the values mentioned in that LCD. That is a very simple LCD, and I am keeping a delay of 3 seconds, and then I am clearing the whole LCD. And again the same thing will happen, and again the values in centimeters, meters and inches and feet will be given in the LCD, and again the LCD will be clear, which is why you saw some sort of a blinking. That blinking is always refreshing the values, and that's very smart, because you don't keep any clearing, which means it will take the measurement once and it will remain with the same, and you have to again reset the Arduino with your button, and then only it will take the next value, and that's very inconvenient way of using this device. So I'm automating that part. Instead I am keeping a delay of 3 seconds so anybody can read it and understand it, and next the LCD clear will be clearing it and refreshing the numbers for the LCD display. So that's how the whole device works. During the next video we are going to make a very useful device same like this. You can use this project for your personal experiments, and make sure you are subscribing our channel, and put comments the projects you need us to work with and explain right here in our channel. And that's it for today. Thank you for watching.